Biology, Part 1. Bioelements. Hundreds of chemical reactions are involved in maintaining life activities of even the simplest organisms. In view of this, it is something of a surprise to find that of 92 naturally occurring chemical elements, only 16 are commonly used in forming the chemical compounds from which living organisms are made. These 16 elements and a few others which occur in particular organisms are called bioelements. In the human body, only 6 bioelements account for 99% of the total mass. This is also shown, and the remaining common bioelements are also listed. Although oxygen, carbon, hydrogen, and nitrogen are among the commonest elements in the environment, they are present in living things in quite different proportions. For example, carbon forms 0.03% of Earth's crust, but represents almost 20% of living organisms. On the other hand, some chemical elements such as silicon, which forms 27.7% of the Earth's crust, are extremely common but scarcely occur in living organisms. The fact that the same 16 chemical elements occur in all organisms and the fact that their proportions differ from those in the non-living world implies that the biochemicals are not in any way an arbitrary collection. Each has special properties which make it particularly appropriate as a basis for life. Water molecules and water ice. Water molecules and ice. Most of oxygen and hydrogen present in living organism is accounted for by water. Water forms about 75% of the most cells, but its contribution to the total mass of an organism depends on whether skeletal materials such as bones are present. In organisms without hard tissues, the overall proportion is often close to 75% of the mass, but in man it is about 60%. Water is a unique chemical substance with a range of important properties, most of which derive from the way in which the oxygen and hydrogen atoms are linked. Each hydrogen atom shares a pair of electrons with oxygen atom, forming a link called covalent bonds. As illustrated, the 3 atoms comprising a water molecule are not in straight line. Instead, the 2 hydrogen form bonds, which are at an angle shown to be 104.5 degrees by X-ray crystallography. You will find this technique explained in the Moix glossary at the back of this book. The nucleus of oxygen atom has a strong positive charge which tends to pull electrons away from the smaller hydrogen atoms so that they are not shared equally in covalent bonds. As a result, water molecules develop partial positive charge near each hydrogen and corresponding negative charge close to the oxygen atom. Such molecules are called polar molecules. The fact that water has polar molecules is the key to many of its unusual properties, because because they are polar and molecules attract each other. This explains why water is a liquid at ordinary temperature and pressure. Other compounds made with hydrogen and elements from group this explains why water is a liquid at ordinary temperature and pressure. Other compound made with hydrogen and elements from group 4 of the periodic table. Other compounds made with hydrogen and elements from group 4 of the periodic table, like hydrogen sulfide H2S, are gases because their molecules are not polar and do not attract anything like the same to the same extent. The electrostatic attraction between water molecules give rise to those linkage called hydrogen bonds. These bonds are stronger when they are lined up along the axis of OH bonds in adjacent water molecules. Electrostatic